Our next quadratic surface is also inherently a function. Here, z is a function of x and y. To analyze the shape, we will analyze several traces here. In our first trace, we see we have a parabola. In the second trace, we also have a parabola. Let's see what those look like. Well, this first one is pretty straightforward, traditional parabola. Okay. As we look from this direction, we're also going to have a parabola. This kind of goes far off into space. And then the last one, x squared plus y squared equals 0. Well, that comes down to a singular point, namely the origin. And so now we graph this. And I'll draw this little shape here showing that it's a parabola. It keeps on going, but it's facing in the positive z direction. And the name of this shape is called a paraboloid. And a paraboloid is a function. In this first example, z equals x squared plus y squared. Because it's a function, I'm going to utilize function notation. So a function of x and y is going to be x squared plus y squared. And this opens in the positive z direction, and it is also customary to identify the vertex in the case that we have a paraboloid. 0, 0, 0 is the vertex. Next example, this one's going to be x equals y squared plus z squared. And I'm going to write this also as function notation. This time I'm going to say f of y and z is going to be y squared plus z squared. And this is a paraboloid opening or opens in the positive x. And the vertex here is also 0, 0, 0, the origin. To draw this one, I'm going to draw this circle, and I'll make the ovally shape here, or parabolic shape rather, and this is the positive x direction. Positive y, positive z. And the graph here, well, it looks like the one above. Our final quadratic surface is also a function. Here, in this case, z is a function of x and y. This one is really fun. We will take a look at some of the traces to figure out what this shape looks like. You will notice at the bottom here that I have z equals 2. That will make for a better analysis. And we see for the first two here that we have parabolas. Let's draw those. The first parabola is facing up or towards the positive z, and the next one is facing down towards the negative z. A little tricky to draw this one with some perspective. So we have sort of opposing parabolas. Now let's take a look at this one. We have this equation for some k greater than 0. So in this case now we're going to have a hyperbola. And that graph will be hyperbola positive y and hyperbola negative y. So this is a little bit hard to wrap your mind around. If you slice it in some directions, you get a parabola. If you slice it in other directions, you get a hyperbola. And the name of this thing is called a hyperbolic paraboloid. But it has a more common name, and that is a saddle, because this will in fact resemble a saddle. And this is a function. So I'm going to show you what this looks like. I'd have a hard time drawing it, so I'm going to pull up some images. So check out this example. X squared minus y squared equals z. This is going to be one of those hyperbolic paraboloids. Let's take a look at the shape. Okay, here it goes. So as we view it from one angle, we have a parabola. As we view it from another angle, this is hidden, we have a parabola facing in the negative z. And then if we view it from yet another angle, we have this hyperbola that comes around like this, and also hidden and then comes around like this. I don't know if you can see that so well, but that would be the hyperbola part of this. And this is now a saddle. Let's draw somebody sitting on the saddle. Okay, so here's their head. Here they come down. Here's their bum. Here's one leg, the other leg goes around the back, and then they hold on for dear life. Okay, so for this guy, let's talk about how he sits on the saddle. You will notice that the top of his head is facing upward. And that's going to be indicated here. So Z is the non-quadratic, and Z will indicate, so the sign is positive, so this will indicate that the top of his head is facing up. Now, we can also describe the saddle based on what axis he is straddling, and here he is straddling, so here's the x-axis. Ooh, that's a terrible color. So here, the x-axis is the axis that he's straddling, and so that is the one, or the term, that is quadratic and positive. Now, interestingly enough, every saddle can be sat on two different ways. Now, this is going to be really hard. Imagine this person's now head is going to be facing downward. So here's one leg. Here's the other leg. And holy mackerel, I don't know if you can see this. This person will be straddling the y-axis, and then the top of their head, you can see maybe their nose here. Here's the nose and the eyes, and this person now is holding on here. So this person's top head is facing in the negative z direction. They are now straddling the y-axis. Okay, but it's the same exact saddle. So what gives? Well, picture the equation we have here above, and now multiply everything by a -1. So we have negative x squared plus y squared equals negative z. And so our little way of memorizing this helps. The z is solo, the non-quadratic, and it's negative, so its head's facing in the negative z. The now positive quadratic term is the y, so that describes the axis that someone would be straddling if, in fact, this were a saddle. Okay, this next one is going to be really hard to draw. In fact, would take some acrobatics to illustrate this, but we can look at it and decide what the shape would look like. Okay, so this is going to be a hyperbolic paraboloid. This, because it's positive, indicates that the top head is pointing in the positive x direction. And now we look at the positive quadratic term, and so we know we are straddling the y-axis. And remember, every saddle can be sat on two ways, one from the top and one from the bottom. And so we write it like this. The top head is pointing in the negative x direction, and you would be straddling the z-axis. There's a matching exercise that I would like you to complete. Next to each of these numbers, you will write the letter of the graph that corresponds to it. Of particular interest would be these two down here. These are obviously saddles, and you can talk about, which way the top head is facing and which axis you are straddling. I think that will help solidify the saddle concept. We will finish part 2 with a couple of equations that you are asked to sketch, identify, and describe. So let's do that. Maybe you'll do it on your own before me, but let's do it now. If I just reconfigure this, I'm going to get x squared over 9 minus y squared over 16 plus z squared over 4 equals 1, so that we have our equals 1 format. Here we have positive, negative, positive equals 1. So you should be able to look at this and decide what is the shape. So what is the shape? This is a hyperboloid of one sheet, and it is tunneling around the odd one out. It's tunneling around the y. This here is the identify part, and this here is the describe part. And now we just have to sketch it. Now, sketching is not a big part of the course, but you should be able to visualize it. So here's the positive x. Here is the positive y, the axis that it is tunneling about. And, of course, we have the positive z. And the next one, we will first notice that this is a function. X is a function of y and z, so perhaps that narrows down our choices. Okay, so what can we take away from this? Well, let's see. We have two positive quadratic terms, and that equals x. So this is telling me a paraboloid, and it's opening in the positive x. And we identify the vertex to be 0, 0, 0. And we've seen this shape before. This one's going to be opening in the positive x. We have this parabola kind of cup, and plus y plus z. Number 3, we also notice that this is a function. Z is a function of x, y. All right. Well, maybe after analyzing this, you've already worked it out, but maybe this will help if you haven't. 2, now I'm going to pull out a negative, and I have 3x squared plus y squared. So we're going to see this as a paraboloid. Now, what influence does this have? Well, it's going to shift the paraboloid up 2 units. That influences the vertex. And then this negative will make the paraboloid facing down, or the vertex of 0, 0, 2. Now, let's draw this. Okay, plus x plus y plus z. I'll choose a different color here. Now, paraboloid is going to shift it up 1, 2 units. And it's going to come down like this. And I just draw the circular shape to get a sense of what this looks like. You know, this technically just goes on forever, this paraboloid type shape. And there we have it. Plus x plus y plus z.